In this video, let us see the bolted connections, types of connections, terminology, grade, failures, and classification of bolts. Bolt is a metal pin with head at one end and shank threaded at another end to receive the nut. And here, at the thread only, the nut can be received. And this is the shank, this is the head, this is the threading portion. And the shank length is called as grip length. And this threading length is known as thread length. And total length is known as nominal length. And you can see whenever we say the diameter of the bolt, that we are talking about the shank diameter. And these are the generally we can use bolted connections in civil engineering structures, steel structures. So we can see the types of bolted connections. First we can see the lap joint. Here two plates are overlapped one by one. There's a single line bolted, so it is called as a single bolted lap joint. And the bolts are in two rows, and it is called as a double bolted lap joint. This is the plan, this is the cross section. The forces are acting in this manner. Butt joint, if you see, two plates are placed one after another, butt to each other, and over that the cover plate will be there. Then they will be connected with the bolts. Is a single bolted butt joint, because it will be having single bolt rows on each side. Double bolted single cover. Here each plate is experiencing two rows of bolts, so it is called as double bolted single cover butt joint. It is only covered by one cover. And is a single bolted double cover butt joint. Two plates are covered by two cover plates, and these are covered by single lane of the bolts. And double cover butt joint, you can see two plates are connected by two cover plates, is a single line butt joint, and that is double bolted butt joint. And here these are a little description about lap joint. It's the simplest type of joint. Plates are connected overlap one another, as we discussed. Lap joints are not generally preferred as they are not comparatively strong than butt joint. Line of action of two forces are not same. So if you see the longitudinal section, one plate is experiencing force in this way, and this is the line of action. Another plate is experiencing the force in this way, and these both lines of actions are not same. So that causes the kind of shearing failure, the easy shearing failure here. The bolt gets into two pieces. And if you talk about butt joint, there is also two shear planes, two cuts, but there is a kind of balancing way. It has two shear planes which balance the section. Two main plates butt against each other. This is what we have discussed during while seeing the diagram. Is the most effective and mostly used. Let us see the terminology also. Pitch distance. So this is center to centers between the bolts parallel to the direction of force. Here you see the direction of force, and in that way this is the center to center distance. Gauge distance, the same center to center distance of the bolts perpendicular to the direction of force applied. Edge distance, here you can see the plate edge, the last bolt to the edge of the plate is the edge distance. End distance is, and you can see this, a plate is ending here, last bolt to end of the distance, or you can see edge distance is the distance between the last bolt to the edge which is perpendicular to the direction of applied load. End distance is the distance between last bolt to the end of the plate which is parallel to the direction of force. Grade of the bolt, so generally it varies from 4.6 to 10.9. So this grade indicates ultimate strength as well as yield strength. So from this 4.6 we can decide how much is the yield strength, how much is the ultimate tensile strength. See here, grade is 4.6. 4 is the 1 by 100th of the nominal ultimate tensile strength. So that means 400 by 100. So that is 4. This 4.6, 4 indicates 400 Newton per mm square. 0.6, 0.6 is the indicates the yield strength of the bolt, which is 60% of the ultimate tensile strength of the bolt. So you have to just multiply the ultimate tensile strength with 400. You will be getting 240. So this is indicated in table number 1 of IS 800. You can check it out. IS 1367. So in section IS 1367, all these are mentioned. 4.6 and ultimate tensile will be mentioned, so that according to the grade, you can decide what is the yield strength of the bolt. Failures in bolts. We can see two kinds of failures. One is a shearing failure, another is a bearing failure. So in shearing failure, bolts cut into two or more pieces, as we have already seen in lap joint. So for double cover butt joint, we'll be having two shear planes. The here failure will occur at two places. Here this image will show you clearly what is the shearing failure. So due to the forces, you can see how the bolt is getting cut into two pieces. Bearing failure is simply the distortion of cross section due to the applied load. Here this circular cross section will change into elliptical shape due to applied force, the distortion in cross section. So we can also see the failure in plates. Generally, failure of joints occur due to two reasons, maybe failure of bolts or maybe failure of plates. We have seen two types of failures in bolts, shearing and bearing. In plates, we can see shearing failure, splitting failure, bearing failure, and tearing failure. Let us see what are all these. Shearing failure is the cracks are developed parallel to the direction of force, and this is a bolt. Here it will be cut off. This is the direction of force. Simply, splitting failure is when you have very less edge distance. So this may occur. This may be splitted into two parts like this. That is a splitting failure. Bearing failure, and if you see, this is actually the position of a rivet. And due to the force applied, the layers are moved in this way, and this bolt is moved, and the hole gets bigger. That is a bearing failure. Tearing failure, you can see in shearing you have seen that the failure occurs parallel to the direction of applied force. Tearing failure, here failure occurs perpendicular to the direction of applied force. So types of bolts, let us see: unfinished or black bolts, finished or turned bolts, high strength friction grip bolts. So unfinished indicates that the shank is left unfinished. So these head may be square or hexagonal. So these bolts are made from mild steel rods. These are ordinary, common, and rough. These are also known as black bolts. So these are used for light structures under static loads such as trusses, bracings, for also temporary connections. And these grades are from M16 to M30. M16, M20, M24, M30, and these numbers 16, 20, 24, 30 indicates the diameter of the shank in millimeters. Finished or turned bolts. So these bolts are made from mild steel hexagonal rods, which are finished by turning into circular shape. These are well finished. These have high bearing and shearing strength compared to unfinished bolts, and the connection is more tight. So these are used in special jobs like connecting machine parts subjected to dynamic loading. And we have even better high strength friction grip bolts. You can see here there will be nut slip. So that grade is very higher, 8.8 to 10. So these are less ductile than black bolts. So this is a medium carbon steel. Previous two are from mild steel, and this is of medium carbon steel. Okay, these bolts provide rigid connection as nut slip is involved, as load transfer is mainly by friction. These bolts are not subjected to shearing and bearing stresses. So these are very strong. So we may need less number of bolts for connection. That's it. Thank you. We shall see the numericals in next video.